So now we're going to be jumping in to percentiles. So welcome back. Percentiles are a little different than what we've been looking at as far as identifying values that are a specific distance away. Percentiles are still looking at location, but it's more in the line of like the median and how we found the median. You're trying to find a value in a specific spot in your data set, or vice versa. So that's how percentiles really should be interpreted. So there's going to be two ways that we can look at percentiles. So the first way is saying, okay, I need to find the percentile that's associated with a specific data value. How would I do that? Well, it's a formula, of course. All right, so the process of finding a percentile that corresponds to a particular data value x is given by the following. Percentile of value x is equal to the number of values less than x divided by the total number of values times 100. So note, round the result to the nearest whole number. So again, percentiles are generally going to be whole numbers. They're not a fraction of a percentile or something like that. So always round it up. Okay, so let's take a look at an example. So we have some sorted values. So right off the bat, they're putting them in numerical order for you, which is a bonus because you really can't do percentiles unless they're in numerical order. So that's important. So they're sorted values, which are the numbers of points scored in the Super Bowl for a recent period of 24 years. And we're going to use that information to answer the questions. So we got all these different scores all the way up to 75. And they want to know what percentile is 47 points. Okay, so let's see, percentile of 47 points should be equal to, so we want the number of values less than 47. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers less than 47. So that's on top. Over the total number of values, which we know is 24. And then times it by 100. So that means we get 0.375 times 100, which is 37.5. Now, based on what the problem or the formula said before, we always want whole numbers. So we're going to round this up to 38. So the 38th percentile. 38th percentile. Now, a lot of words in there, so we don't like that. We're going to just use the notation form, which is just P38. So that's a lot more succinct. So now, let's just do it one more time just to make sure we got it down. So let's do the percentile of 54 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 numbers are less than 54 out of the 24 times 100. So I think we can see that that's going to be 50%, right? So the 50th percentile, or P50. So pretty easy to identify the percentile that's associated with a specific data value. Now, when we reverse the process, it's a little bit trickier. It involves 2 layers to the process. But before we get to that, let's just take a look at some notation that's going to be important. So N is what N has always been and always will be. And that's the total number of values in the data set. Okay, so that's the same. K is the variable they use for the percentile that's being used. So L is going to be a new variable, which we're going to explore. And that's going to be the locator. That helps give us the position of a specific data value. And then P sub K is the kth percentile. So L is what's going to be the first step of this process. We got to find the location. So the formula is equal to L equals K over 100 times N. Very, very quick formula. So again, K is the percentile, N is the number of values in the data set. So now these next couple of examples only want you to find the locator values based off of that example from above, the Super Bowl scores. So We're not really looking at the Super Bowl scores yet, but we will be, because right now all we care about is those locator values. So what would L be for P70 for this data set? Well, so 70 is our value of K, so that's going to be on the top, over 100, and then times, and then how many numbers were in our original data set up there? 24, right? So if we divide, so 0.7 times 24, 16.8. Okay, so 16.8 is L. Now we're going to see what to do with that in a minute, but let's just do the other one just real quick. So if we wanted P21, what's our locator value for that? Well, so K is now 21 over 100 times 24 and 5.04. So not anything drastic to do on your calculator, so just be careful though. But now what the heck do we do with it? Well, that's what the next page is going to tell us. So a flow chart. Now it's a little hard to see, I know. So get a magnifying glass or look in your textbook, your online textbook, and you can zoom in. But for this flow chart, we're actually starting in the middle. We've already found L, so the question is, what do we do with it? Now, the question, if you can't see it, it says, is L a whole number? So it's either yes or no. Most of the time it will be no, but there will be some instances where the answer is yes. So, but let's start with the no, because that's what we had in both of our previous examples. It says change L by rounding it up to the next larger whole number. And that's important that you see that word up there. It doesn't say to round down. It doesn't say to leave it alone. It says to round it up. Always round it up for this particular application. And then it says the value of P sub K is the nth value counting from the lowest. All right, so again, it's telling us where to look in our data set. So now that we know that L was 16.8, that based on our flowchart, we have to first round it up. So the 17th value in our data set is going to be our answer. So P70 is equal to the 17th value. Well, we got to go back. 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 57 is in the 17th spot. So that must be P70. And don't forget your units. So percentiles do have units based on whatever your data set is talking about. All right, so what about P21 now? L was equal to 5.04. Well, even though it's a lot closer to 5, we can't round this down. The rule says to always round it up, so we got to round it up to the 6. So the 6th value in our data set, and let me just look real quick. 1, 2, 3, 4, 5, 6. Looks like 41. So P21 is 41 points. And so that's it. So that's the process for looking at percentiles in both directions. So if you're trying to find the percentile based on a specific value, you can do it. Or if you're looking for the value that occupies a specific percentile, you can do that as well. A little bit more to it, but we're going to do some more examples in a second. So we'll do more in the next video. See you soon.